Hello and welcome to another past paper walkthrough where I will be going over the June 2021 Edexcel iGCSE Computer Science past paper. But before I do, I'm going to ask you to please subscribe, like this video, subscribe to my channel and share it far and wide. Without further ado, I'm going to go over the paper 2 past paper, Application of Computational Thinking. So this is a programming paper. Yeah, I'm not going to go through all the instructions and all the blah-de-blah. You can read that on exam day. We know the languages we've got to do, either Python, Java, or C#. In this case, we're going to be doing Python. So we have to basically do it across to say, right, it's Python. Let's go and give this paper a whirl. Computer programs make use of many programming constructs. So we have to identify which one of these is a logical operator. So you've got modulus, or greater than or equal to, or the equal sign. Process of elimination. It's not going to be equal. That's assignment. It's not going to be modulus, arithmetic operator. And it's not going to be greater than or equal to. That's a comparison operator. So we're left with or. So the three logical operators are or, not, and. Those are your logical operators. Okay. Part B. Describe one difference between a one-dimensional array and a two-dimensional array. So, in that one, a one-dimensional array will represent items as a list, whereas 2D will be represented as a table with rows and columns. Okay? Okay, now we're on Q01C, so that's the first of the Python files we need. So the program should calculate how many 20s are spent on £113 and how much is left over. There's 3 errors in the code, and we're going to amend the code to correct the answers. Then we save the amended code as Q01C finished with the correct file extension for the programming language. Let's have a look and see what we got to do. So, already, there's some errors. Let's see where they are. There is, so we could have had a comma, and we don't need the plus, we need another comma. So we've got the quotes there, and we've also got leftover an amount, and perhaps we forgot a comma. Yes, we have, so we put that in there. So let's run the code. Cannot do that, so it's still left over, and it's a string. We don't necessarily need a string in this one. Left over. We definitely don't need it. We forgot. We got a syntax error. We know it's invalid. We've got a comma here. I should say left over. So what I should have done is shift minus to get that. Num20s. That should be equal to amount. Let's run it. And there we go. So that is all our errors removed. So num20s, when we're doing a working, you're meant to have 1 equals, not 2. So that was one of the errors, 2. We just needed a 1. Another error was the comma. Not having a comma here, and not having a comma here. You can do the plus, but the only time I do pluses personally is when we're concatenating strings, which in this case, we're not. And that's our answer. So what I'm going to do now, I'm going to delete I'm going to delete this one because we are done and we do not need it anymore. (1D). We've got a program that counts the number of words and vowels in a sentence, and we're going to open Q01D. So we're going to open that up. Yep, we're going to open this one up. And we're going to run it and we're going to see what's going on. So I'm going to input a sentence like, hello there. Number of A is 0, E is 3, I is 0, O is 1, U is 0. So it's counting the number of vowels. So we're going to amend the code by adding a suitable comment. You may need to add more than one comment in a line. At the end of the line, so we need one where there's a relational operator, iteration starts, selection starts, data structure initialize. So I would say here, data structure is initialized, because lists and arrays, they're data structures. Here I would say where iteration starts. Then we need one for selection. And then we say where selection starts. So that's where selection starts. Yep, so still counting the number of vowels in that sentence. What else do we need? We got data structure, iteration, we got selection. Now we need to find the relational operator. So let's have a look down. And see where this relational operator is. So if vowel is equal to letter, so we've got here relational operator, which I always call comparison operators. Because as if vowel is equal to letter, then it's going to go num vowels index, not that, it's going to go num vowels, then vowels.index vowel, and then increment that by 1. So that, ladies and gentlemen, is Q01D, which we'll delete because we do not need it now. And we're going to delete that, and we're going to get rid of this. Nice and easy. 2. A book club uses computer applications. The club wants a program to ensure logins are valid. Flowchart for the test version of the program has been designed. So we've got a username and we've got a password. Here is a flowchart that we need to follow. So we start, we're going to initialize a variable, enter username and password, and they're correct. If not, we go back. And then once it is correct, we display a welcome message and we stop the program. So we need to write a program to implement the logic of that flowchart. So we need to open Q02A in the editor and use the structure given to write the program. So we cannot add for any more functionality than that. So let's have a look and see what they got. So where do we begin? Well, let's break it down. So I would be doing variables like username, 2 strings, password, 2 strings. So I'd be doing that. Password there. Print the prompts, check and take input from the user. So we need to ask the user username and password. Input, enter your username and we're going to ask them to enter your password. Going to ask them to enter the password. And then what we are going to do, we're also going to have in here, count is 0. Then we need username and password. In fact, we're going to change these variables, and we're going to have input username, input password. Then we have username here, and we're going to have password here. And they're going to be based on these. On these here. So we got the username, and we got the password. So there we go. So that's what we want. And then we want and then we're going to want a while loop. So whilst username is not equal to input username, or the smartest way to do it is whilst input username is not equal to username, or, this is where we need an or operator, input password is not equal to password, boom. And then what we need now, if count is greater than 0, then what we're going to do, we're going to say there's a problem. So incorrect. So we could say incorrect username or password, try again, or we could say there's a problem. Doesn't really matter so much. Then we're going to have count equals count plus 1, because we're going to increment the count. And then what we're going to do, we're going to input username and password. So we're going to use those. Enter username. Enter password. Nice and easy. And then we're basically doing a print statement at the end. Nice little print statement. Welcome. You want to. So let's have a look. Okay, I can't do that because something's wrong. And it's making me enter username again. So if I get rid of this spacebar we don't need, I'm going to try this again. And then once I press it, that's going to say welcome. Okay, so that is what we do. So what we've done, we've initialized the variables, username and password. Count, we initialize that to 0. And input username and password, we initialize those to empty strings. But we get the user to input those strings anyway, because we don't know what the user's going to type. So while input username is not equal to username, or the input password is not equal to the password, then it's going to make us try again and again and again until we type in the right name, until we type in the right characters to do this. And that is question 2A. I'll load up question 2B. And let's see what the question is. A club sells books. We need a computer program to monitor. So we need to monitor the number of books sold and the amount of profit made. So 2B provides structure for the program. So we got Q02B open. We need to amend the code to complete the if statement used to produce the outputs which we're going to describe in the table. So we've got if number of books sold is at least 5. So we need if books sold is at least 5. So we're going to go greater than or equal to 5. Or profit is greater than or equal to 10. Which means the profit made is at least 10. Okay? And then what we want is we want number of books sold is over 20 and the profit made is at least 20. So we want books sold to be 20 or profit to be greater than or equal to 20. And then in the last elif, we're going to have number of books sold is under 5 or profit is under 5. So we have books sold is less than 5 or profit is under 5. So less than 5. Else, we're going to print alert manager. So if we're going to enter this, it would be I've sold 2 books and I've made 10. Poor performance. I've sold 15 books and I've sold that for 40. Still a poor performance. 50. So poor performance. So we've got some problems in our code. So it needs to be at least 5 or more, profit at least 10. So let's have a look. What we should have done was we got or, and we should have used the and operators. These, not the ors. And we got some of the comparison operators wrong. So let's say I wanted to do 5 and I wanted to do 10. Let's say I wanted to do 11 and I made 15 quid. Still poor. Let's say I wanted to do 24 and I'm going to do 25. That should still not be a poor performance. So if books sold, is less than 5, or profit is less than 5, poor performance. And let's say for sales are good, at least 5 and at least 10. So we should have had greater than or equal to, greater than or equal to. And then we should have done the same. For extra performance, there should have been 20. Let's give this a go now. So I'm going to do 5 and 4, poor. 12 and 15, good. I'm going to do 30 and I'm going to do 100. Sales are excellent. And anything else, anything else, basically alert the manager. So that is our code for 2Q02B. So we'll delete that because we don't need it. And now, so that's all we do. We don't add any functionality. 2C. Boundary testing is an important part of program development. So the boundary value is the most extreme value that will pass the test. So if the boundary condition is no more than 30, then the boundary test date will be 30. So we've got to complete the test now. So we need to test this code. So we're going to test this code that we've essentially done. So book sold, poor performance this week. So let's say we want to get a poor one. So I'm going to do 4 and 4. 4, 4, poor performance. Let's say I want to do something for good performance. I'm going to do 25, 25, which would be excellent. So we would pop that, 25 and 25, in our excellent. For good, we would have something like 15 and 14. Then we say the cells are good, and we bung those in the table. Okay, so let's have a look and see what they actually wanted. Yep, so I had a book sold, a profit being a 4. Could have 5 and 10, 21 and 20, but I've chosen numbers that's within that range anyway. So you can test those exact numbers, or you can test them within that range. Okay? Next one. Let's have a look at 3A. Several encryption algorithms have been developed. So Ahmed has decided to create a Caesar cipher encryption program. So Caesar cipher encryption works by giving a number of value to a key. So each letter in a plain text message is replaced by a new ciphertext letter using a key. So in a table, we've got a key value of +2, would change the plain text message to encrypt the message to GP pet arv rather than encrypt, because we're going by 2. So E plus 2 is G, and go to characters as a P, C, now go in E, and so on. So Ahmed's program already converts from plain text to ciphertext, as we will get into. So I will get this program up. Yes, it's quite a big, hefty program. So that's a big, hefty program here. So it already does some of the work, converting the ciphertext. So he wants to extend the program to accept a plain text message, accept the input of the key, which has to be a positive integer between 1 and 25, write a generated ciphertext to a text file named cipher.txt, and then display that ciphertext. So that's what he wants his program to do. So let's see how that works if we were doing this. So plain text, we would have we're going to add the code to get the plain text. So we need plain text. So plain text, and that's going to equals, that's going to be input, enter the plain text. And what we're going to do there now is we're going to do plain text equals plain text lower. So that's going all to lowercase. So that's the first bit. And then what we're going to do in the add your code, so it's between 1 and 25, so we're going to do while. And then what the variable is, so while key is, so while key is less than 1 or key is greater than 25, we're basically going to ask the user input the key again. Yep, so it's a key int input. So enter the key again, and that's what we need there. So we've got asking you to input the plain text and making sure that the key is between 2 1 and 25. And then what we want to do is add the code to the ciphertext. So we need cipher file is open, and we want to do ciphertext.txt, not text. And then what we want to do, outside the quote but inside the bracket, comma, another quote, W. W means write. Then we want to write then we want to do cipherfile.write ciphertext. And then we want to do cipherfile close. And then we're going to add our code to display the ciphertext. To do that, we just do the ciphertext message is, and we are going to call that ciphertext. So let's run that code. I'm going to enter, hello there, you are a bold one. Enter the key again, and I'm going to shift that to 0. Don't want to shift it at all. I'm going to shift it by 55. Can't do that. I want to do a 0 though. I want to do 44 though. So I'm just going to do 4. So H, we got HIJK. We shifted that 4, so that goes to L. E, so EFGHI, 4. L, we shift that 4 to P, and so on. So that, ladies and gentlemen, is question 3A. And that's that one done. So now we have to explain why a Caesar cipher is a weak encryption algorithm. So why is it a weak encryption algorithm? So that's what we need. Why is it weak? Well, it can be easy to find commonly used letters and guess the key. So we can find the letters easily and the key, and we can find the key. Those are the two reasons why Caesar cipher is a weak encryption algorithm. What you could also have had, you could have number of keys are limited, making it easy for brute force to decrypt. So what you'll find is it's just copy and paste the mark scheme. Right. For C, we got the Vigenère cipher encrypts plain text using a series of Caesar ciphers based on the letters of the keyword and a Vigenère square. So figure A shows the whole square. So we got AA, yeah, B's, and a C, loads of C's, D's there, and an E. So you can see this. So it's quite a jumbled up, complicated thing there. So you got A and A, B, then you go below B, B, and you go this way. C, go down one, then you start to go diagonal. D, go one right, then go diagonal, then up. E, one down, diagonal, left, and so on. And you get that with a load of letters here. So we got to complete the table to perform this decryption of the ciphertext message with the keyword 30. So you got your encrypted letter, got the keyword, and we need the decrypted letter. So how we do that is a bit of a big one. So let's say we need to find F. So find our F, and we will need to go to, to keyword letter being a T, which means so F is encrypted. So we basically need to find keyword letter says T, so the decrypted letter is going to be M. L, H and E. So L is a difficult one, so L we need to find H and E. Ooh. Yeah, so we need to encrypt plain text using lots of Caesar ciphers. And that's based on the letters of a keyword in that square. So these are like the letter starting points, and then these are the letters inside. Let's say we want to find M. So M, and we want to find, so we need to, so M and I. So M and I. M and I. M and I that way is a U. M and I is a T. Yeah, it looks like a really complicated Wegener square. Okay. So we're going to find the F, L, M, K, T, R, W, H, E, E using the keyword 30. So we're going to find it using the word 30. And all it's got on the mark scheme, and there is no additional guidance, which is not very helpful. So that needs to be mapped to 30 there. And then the F, L, M, K, T, R, that's got to be mapped to 30. So that could be one of the marks. So that'd be one of the marks for one of those two bullet points. Then you would need one letter decrypted correctly, at least one keyword decrypted correctly, and the decrypted message is meet at dawn. But how you get them to meet at dawn, that is a big one. So we want F. So F, and we want or T. Yeah, which looks like a really strange one to do there. So let's have a look now. Let's have a try again. So what we've got down here, encrypted letters F. So in the keyword letter, we would need to do something like, okay, can't edit in here. So you need T H I R T Y, T H I R. So 33rd, and you just keep going for as long as however many encrypted letters there are. So F and T. So you've got T here, the low one. So think of it in terms of X and Y coordinates. So X first, then Y. So you got your T. So we need to go. So you got your T. We need F actually. T, we need to find F. So we got F, so we need to find T. So if we go up to F, so we got F, or we have T, So when we're doing a T, so we need to find the first F in that T row. So we got F here, which we found, and then we go up to M. So hence, we just put an M here as our decrypted letter. Let's do L and H. So we've got your L. So we need to find a H now. So we've got our H. So we've got L, and our keyword letter is H. H. So in L, we need to find H. Or H. So you need your H, then your L, which is your E. And then we need an M, which is our encrypted letter. And the keyword letter is I. So we're going to have I. And I'm going to, so we got I here. We're going to go to M. And then we're going to go to E. So that's another E. So eventually, what we should have should be meet at dawn. So that, by doing that, would get you 4 marks. So you get at least one letter decrypted correctly will get you 1 mark. At least one word decrypted correctly will get you another mark. If you have the meet at dawn, that's 3 marks. If you have just having that mapped, will get you 1 mark. So that would get you 4 marks altogether. Okay? Yeah, that looks like a tough question, but once you get into it, it's not so bad. So let's move on to D. So we use a defined function, uses a Wegener cipher to decrypt plain text into ciphertext. So this pseudocode will show how the function's called. Set ciphertext to ciphertext and get cipher letter, keyword letter, plain text letter. So state what would be returned by this function. So let's have a look. It'd be cipher letter, or you could have a single encrypted letter. If we were to give the name for one parameter passed to this function, it could be keyword letter or plain text letter, which is one of those two would get you 1 mark. They don't care about the case. They just care that you've got keyword letter or plain text letter. Then the last one on this question, state what is meant by a built-in subprogram. So it's basically a subprogram already defined. Yep, so that would get you 1 mark. Or, alternative, you could have subprogram that's already written, that gave you another 1. Subprogram that's already compiled, that would get you 1 mark. Or you could have subprogram that can be called without having to write code for it. So any one of those would have got you 1 mark. So you only need one of those bullet points. So if you remember the theory, it's literally copy and paste the mark scheme. Let's go to number 4 now. Zach sells snacks at an after-school club. He wants a program that will hold the details of the products he sells. So the program must generate a 5-character product code that starts with the first 3 letters of the product name, ends with a random number between 10 and 30. Then we display the product code followed by the product name. So we need Q04A. So we don't need this anymore. So let's go into Q4A. And it's given us the import random. So yes, we are going to need it. So first things first, we need to get the input. So generate 5 characters of code. And it's always good to see what the mark scheme wants as well. So we need product name. So we need enter the product name. So that's That's one we need. And then we will need random number being a naught. Then we need to generate a random number between 10 and 30. So random would be random.randint 10 and 30. So you could assume that they're inclusive. And then we want product code. And that will equal to product name being upper and then str to random. And then we will want to display the product code. So we want to print the product code. And then is product name. So let's have a look. So I'm going to enter bottled water. That's a number generated there. I'm going to enter to the tuna. I like my fish. And there we go. Tin 25. So we could say something like, I don't know, potato salad. Pot and 11. So it's just going to randomly generate these different numbers between 10 and 30. Okay, how many more have we got on this one? Zach plans to implement binary search algorithm to search a table of products. So we've got to explain one advantage of a binary search compared to a linear search. That's worth 2 marks. So it wants us to explain. So it's 2 marks for a good explanation. So an example explanation could be, binary searches can be quicker. That's 1 mark. And binary search halves the list each time. That's 2 marks. Or you could have binary search halves the list each time, so it could be faster to find an item. Or you could have binary search can be quicker, as it does not have to examine each item in the list. So any of those will get you 2 marks. Okay? So let's go down and have a look at another. So a lot of this is theory-based now. So figure 2, we've got an algorithm for a binary search. So the binary search algorithm will be used to search the product list for the product str15. So we need to complete the table that will indicate the order in which the product codes are examined by the algorithm. So write the number 1 by the first product code to be examined, which is a 2, by the 2 by the second, and so on. And that would be, so for 4 marks, you would need 1 in position 4, 2 in position 6, 3 in position 7. And that would get you the 4 marks right there. Okay? So if we were to have a look, so position in the list, so we'd have 1, 2, and 3. Okay, let's have a look at these two. Zach has another list containing names of 5 students who attend the after-school club. So we're going to give the maximum number of names that need to be examined by the binary search algorithm to determine whether the name appears on the list. So it's 3, or we could have log n plus 1. Doesn't really matter in this case, so you could just say 3. And then the last one, give the name of the algorithm that could be used to sort the list. So you have bubble sort or merge sort. You can have insertion sort, but in this case they only want bubble sort or merge. Okay. And the final question, which we'll get to once we get some logistics, programming logistics on the ready. So this is our base code that we've been given. So it's quite involved, this one. So the program displays a menu already and asks the user for a menu choice. So now we need to add the player name. If the player chooses this option, they must input a player name. Otherwise, we have to play Guess the Capital City. So if a player chooses that, got to complete 5 questions, select the question to answer by choosing a valid question number. Each question will be selected once. Question should be displayed. Input the name of the capital city. Guess correctly, score gets incremented by 1. If they guess incorrectly, correct answer must be displayed. Menu choice 3, end the game. So if a chooser uses this option, then the player name and score will be displayed. And the program should function correctly even if the number of countries and capital cities in that file has increased. So we've got the menu choice, M choice, and add the player name. So this looks quite involved. So let's break this down. Let's go through bit by bit. So in a menu choice, so this is in the band. So it's a 9 marker. So ideally we want to get to the 9. So the code has to be clear and it has to be readable. Program has to be decomposed into component parts. Logic is clear and appropriate to the problem. Use and manipulation of data types, variables, and data structures and program constructs being appropriate. And the finished program could be used with other data sets or input. Program will then fully meet the given requirements. So how are we going to do this? So we've got the add player name function. So we will have player equals empty string. That's the first bit. Second bit, we want. So basically, while player, there's nothing there, we're going to get the player to input, enter player name. That is the first bit. And then what we're going to do there is we're going to return player. That's that done. Now what we want to do is guess the capital. So we've got to partially complete the program here. Display the question, check the guesses, return the final score. So we're going to add our code now. So while question count, so we want while question count less than or equal to 5, do question choice -1, then we're going to do question number equals that, and then we are going to do build a string so we're going to build a string containing the question available. So for question in questions, we're going to have if question is not equal to 0, then we're going to have question number is alt equal to str question. I'm going to have empty strings there. Then what we're going to have, we're going to ensure a valid question number is there. So ensure a valid question is inputted. So here, so while string is, so we have while string, so we've got build a string containing. So we're going to build a string there containing the question numbers available. So we've got that one. Then we've got going to ensure a valid question is inputted, is chosen or inputted, doesn't really matter. So how are we going to do this one? We're going to say while string question choice. So whilst we're saying question choice, not in question number. So while that's not in question number, we're going to ask them to pick a number. So we're going to pick a number from, and then we're going to use the question numbers variable. We're going to use the question number variable. Then we're going to do country, and we're going to do capital. So get the country and capital. Equals countries. And then we're going to do question choice +1 or -1. So we're going to do that. Question choice -1. Then we're going to do capitals. Question choice -1. These are actually square brackets. So they're not used, which is not a problem. So we need to display the country and get the guess. So we're going to guess, input, what is the capital? What is the capital? That's what we're going to have. Then if guess, so we have if the guess is, yeah, so we're going to check the guess. So if the guess is equal to capital dot lower, we're going to say, well, well done, and we can say you guessed correctly. else we're going to say you did not guess correctly, and say what the capital actually is. We're going to have question equals question. So we're going to have question count equals question count plus 1. And then you're going to have questions, question choice. So you're going to take those again. So we're going to take those again. Do questions, question choice. So we have questions, choice minus 1 is equal to 0. Why you got two at the same lines? That's no idea. And then we're going to do return question score. So we've got that function there. And now we want the main program. While menu choice is this. So if menu choice is 1, we're going to say player name and player name. And if menu choice is equal to 2, we're going to say score equals guess capital. And then we are going to say else. And we're going to print well done, player name. Yep, so we're going to say well done, your score is, then the score. And that will be it. Let's run this big program. I'm going to input and player name, me, play the game. I'm going to pick it from 1, 2, 3, 4, right. That is not actually working. So why? So why is that not working? So our question count and everything except the return is in that while loop. So we got everything in that while loop there. And I mean everything. Let's try 3. We've ended the game. So let's run that again. 2. So it's asking us to pick a number. Pick a number from the question number. So I'm going to pick 1, 2, 3, 4, 5, 9, 0. It's just making us pick that number. So, got a bit of a problem. So it's just making us pick a number from question number. And then what I should do is should get the country and its capital. Or make us keep guessing. So there might be something wrong with a question choice. Well, that's not in question numbers. We'll try that. So we've got something wrong there. So while the question counts, make that a 5. So that's not working there. So there's something wrong with the code. We've got question count is 1. Where we need to have it. So we don't have the question count and the question score, which is what we need. So we need question count is equal to 1, and question score is equal to 0. So we should have had those two variables. Let's try 2. That's still not doing anything. So I should have put that in a capital city function. So question count, question score, which I've already got. Then we're trying to go into this while loop, which is all. Then we're trying to go into this while loop. Question choice is -1. Question numbers is 0. Question choice is this. Then we've got countries and capitals. Question choice is -1. So it looks like the mark scheme doesn't have something that's working, which is a bit strange. But hey, so that is strangely the code. Why that's not doing anything, I don't know. Sorry it took so long. I now just realized that what I should have done is I should have done question numbers plus equals rather than not equals. So when I run it, I'm going to get number 2. So I can pick any question. So I'm going to do 1, capital of England, London. Sorry, capital is London, even though I put it in there, which makes no sense. Right, let's try 2. Pass. Well done. Guessed correctly. Number 3. Madrid. Let's try number 9. I'm going to pretend to be wrong and say Peking when it's actually Beijing. I'm going to say 6. Edinburgh. So correct is Edinburgh. So I'm going to end the game. My score is a 1, which shouldn't be the case. But this question is worth 20 marks. So even if you get some of it wrong, you're still going to get some marks. So like, we got the menu choice to work and we got the end game to work. So you will still get some marks there. We've got the 5 questions, so you still get some marks there. Select the question to answer by choosing a valid question number. You're still going to get marks, so we got that to work. Each question only selected once, got some marks there. Question should be displayed. Input the name of the capital city, we've got those. We're guessing correctly, correct answers displayed. So the only thing we haven't got is we got the score being the 1, even though we've got, even though I got the correct answers. So what they would have wanted because the way we've done it was all this is lowercase rather than uppercase. And enter 5. So what I should have done there was just do all lowercase. That's how we get it correctly. So I'm going to end the game. So the score is a 3. Okay? And that is the whole of the paper. Like I say, reason why I've gone for showed you the mark scheme as well is because I like to show you the type of thing that they would be looking for. That's why I show you the mark scheme as well as the question and doing it all together, basically. And that is the entirety of the 2021 paper. June 2021 paper. And there we have it. I hope you've enjoyed this video. Please remember to click that like button on this video, subscribe to my channel, and share this video and channel far and wide. And I look forward to making the next video for you very soon. Goodbye for now. Thank you for watching.